Okay, we're going to do a quick video on operations that involve the radical symbol or square roots. The radical symbol is a grouping symbol. It is a grouping symbol. So if you think about our order of operations, we want to do the radical stuff first. And before we can take a square root, we have to evaluate the radicand, or what's underneath the radical sign, first. So we're just going to do 4 quick examples, and then I'm going to show you how we find the square roots of non-perfect squares. So example 1, we have 5 times the square root of 36 plus 7. 5 times, first I need to do the square root of 36. Square root of 36 is 6. 5 times 6 plus 7, 30 plus 7 equals 37. So again, we did our radical first. Example 2, 1/4 plus the square root of 18 halves. All right, so in the last video, we talked about if we have the square root of a fraction, we square root the numerator, square root the denominator, and we leave our fraction. In this case, 18 and 2 are not perfect squares, so they're not easy to find that square root off the top of our head. But if you notice, what if I evaluate the inside first? 1/4 plus the square root of 18 divided by 2. Well, 18 divided by 2 would leave us with 1/4 plus the square root of 9. And 9 is a perfect square, giving us the square root of 9, which is 3. So this would be 1/4 plus 3, which is 3 and 1/4. So sometimes if you check, hey, can I simplify it underneath the radical, it might make it a little easier for us. Oh, sorry, you can't see that. Example 3. The square root of 81 squared minus 5. If you recall from the last video, square rooting and squaring undo one another. So if I square root something, but then I square it, I end up canceling each other out. And think about the square root of 81 is 9. 9 squared, 81. So this leaves me with 81 minus 5, which equals 76. And our last example. I'm going to evaluate the radicand first. So this gives me the square root of 12 plus 13 plus 2 times the square root of 49, which is 7. This gives me the square root of 25 plus 14. The square root of 25 is 5 plus 14 equals 19. And that is how we can evaluate expressions that involve square roots. Now, before you go, the last thing I said I would show you is what do we do if it's a square root of a non-perfect square? So what if I take the square root of, let's think, something that's not perfect, the square root of 13. On our calculator, we can do that with every calculator is a little different. So this calculator is definitely different than maybe what you're used to, but you're looking for that radical sign. You're looking for that radical. So usually it's just going to be on one of your keys or on a calculator, a phone calculator, something like that. So if I hit that and I want 13, I just put in 13 and it's 3.6055512. We're just going to round it to the tens place. So I'm going to say it's about 3.6. About 3.6. Oh, I always keep hitting the wrong button. There we go. If I want the square root of 32, now I can actually think about that. 32 falls between the perfect squares 25 and 49. So, or not 25 and 49, 25 and 36. So it should fall between 5 and 6, the roots 5 and 6. So again, square root of 32, 5.66 between my squares. So that's how we can use a calculator if it's not a perfect square. And that is using radicals in expressions or order of operations, however you want to think about it.